You know, the complete instruction manual for every living thing on this planet, from a gigantic tree, to your dog, to you, it's written in a molecule that's literally everywhere, but it's completely invisible. Well, today we're going to change that. We're going to make the invisible visible. So that's the big question, right? How in the world can you take the microscopic blueprint for life itself and pull it out into the real world, big enough to actually see, to actually touch? It sounds like something straight out of a sci-fi movie, but you're about to see it's a lot simpler than you think. And the secret? Well, you don't need $1 million lab. Nope. All you need is a strawberry, a little dish soap, and some basic kitchen chemistry. We are about to become molecular biologists using stuff you've probably got lying around right now. To pull this off, I want you to think of this like a heist. The DNA, our prize, is locked deep inside a microscopic fortress, the plant cell. Our mission is to break through all of its defenses and get that prize. Now, this fortress, it has 3 separate layers of security. First, there's a really tough outer cell wall. If we can get past that, we hit a greasy, fatty layer called the cell membrane. And if we get through that, we're at the final vault. Another greasy membrane, the nuclear membrane, which is where the DNA is kept safe. We've got to bust through all 3. Every good heist needs the perfect target, one that's easy to break into and has a massive payload. And for extracting DNA, there is no better target than the ordinary strawberry. It's soft, it's easy to mash up, and for one very special reason, it is absolutely jam-packed with the goods. So here it is. This is the strawberry's secret weapon. See, most organisms like you and me were what's called diploid. That means we have 2 sets of chromosomes in each of our cells. Strawberries, on the other hand, are octoploid. That 8N means every single one of their cells has a whopping 8 sets of chromosomes. That is a ton of DNA for us to grab. To put it simply, if our goal is to get a big clump of DNA that you can see with your own eyes, well, starting with a target that has 8 times the material gives us a massive head start. I mean, bananas and kiwis work too, but the strawberry is really in a league of its own when it comes to a huge DNA payout. All right, so we've got our high-value target. Now we need our demolition crew. The plan is a 2-pronged attack to smash through those fortress walls we talked about. It's going to be a little bit of brute force and a little bit of chemical warfare. The first attack is called physical lysis, which is just a fancy way of saying we're going to mash the strawberry in a bag. That's the brute force that shatters the tough outer cell wall. Then comes chemical lysis. That's where our dish soap and salt come in to do the more delicate work of dissolving those greasy inner membranes and finally setting the DNA free. And honestly, it's that simple. Those inner membranes of the cell are made of lipids, which are basically fats. And what is dish soap designed to do? Cut through grease. So when you add that soap, it just tears those fatty membranes apart, spilling everything inside, including your target, the DNA. Okay, so what about the salt? It plays 2 really critical roles here. First, it helps clean up the DNA by knocking off all these proteins that are usually stuck to it. But its main job, its most important job, is neutralization. DNA strands naturally have a negative charge, so they repel each other, they push each other apart. The positive ions from the salt basically create a shield around the DNA, canceling out that charge, and finally allowing all those strands to start clumping together. Okay, the fortress walls are breached. The DNA is free, it's been cleaned up, the heist is almost complete. All that's left is the final, kind of magical step, making the millions of invisible DNA strands clump together into something we can finally see with our own eyes. But hold on, before we do this, a super important pro tip and a safety warning. This part uses rubbing alcohol. It's flammable, it's an irritant, so please make sure you have adult supervision. It's absolutely non-negotiable, and for this to work for the best results, that alcohol has to be ice cold, like straight out of the freezer cold, and you're about to see why. Now, your technique here is everything. You can't just dump the alcohol in. You have to pour it very gently down the side of the glass so it forms a separate, clear layer on top of the red strawberry goo. If you shake it or mix it, the DNA just scatters and becomes an invisible cloud. But by layering it, you concentrate all the DNA right at that boundary, and that's what creates a visible clump. So why does it have to be ice cold? Well, there are 3 key reasons. 1, DNA doesn't dissolve in alcohol, so the alcohol forces it to clump together. 2, the cold temperature just makes that clumping happen even better. And 3, and this is probably the most important part, The cold literally freezes these tiny little destructive enzymes that would otherwise chop up the DNA into bits. Without that cold, they destroy our prize before we ever got a chance to see it. So you've done everything right. You've mashed, you've mixed, you've carefully layered that ice-cold alcohol on top. Now you just have to watch. Stare right at that line between the strawberry liquid and the alcohol, and within just a few seconds, something pretty incredible starts to happen. Now, don't go expecting a perfect, beautiful double helix to appear. What you're actually looking for is a huge glob of millions and millions of tangled DNA strands. And the source material describes it perfectly, if not a little grossly, as a white, cloudy, stringy, whitish, snot-like material. And that's it. That's the good stuff. You are literally looking at the blueprint of life. So, mission accomplished. We did it. We pulled visible DNA out of a strawberry using kitchen supplies. But what's the big takeaway here? Well, the amazing thing is that this isn't just some cool party trick. This is real, fundamental science. Those core principles you just used, lysis to break the cells, purification to clean the DNA, and precipitation to make it visible, those are the exact same steps that scientists in the most advanced labs in the world use every single day. Sure, their tools are a little fancier, but the basic science? It's identical. And this process, just getting the DNA out, is the absolute first step for so much of modern science. It's how forensic teams solve crimes. It's how medical researchers create new vaccines. It's how we can study the DNA of animals that have been extinct for thousands of years. It all starts right here with what we just did. So we just went from a simple strawberry to holding the code of life in our hands. It really makes you wonder, doesn't it? Now that you can actually see this code, what other incredible secrets about our world, about our history, and even about ourselves are just waiting in there to be unlocked? Thanks for joining this explainer.